coming. Ending its 13-year mission, Cassini is all set to plunge into Saturn's atmosphere for its grand finale. On Friday, September 15, Cassini will enter its last flyburn of Saturn, resulting in its crash into the planet. The spacecraft was sent on this collision course in April this year, which lasted 22 orbits and will end around 11:32 a.m. BST.
Things happen super fast. So let's look around the room.
ACS is nominal. We're in low rate mode and we're waiting for high rate mode transition. Copy, thank you.
So that was
indicated. Fault protection system lead.
Go ahead, system lead.
Just going to get a quick subsystem status, please.
ACS fault protection is nominal.
Copy, thank you. Thermal systems lead.
Thermal devices subsystem is nominal.
Copy, thank you. Power systems lead.
Power subsystem is nominal.
Copy, thank you. System fault protection systems lead.
System fault protection is nominal, no fault protection activity.
Copy, thank you. CDS systems lead.
Pressures and temperatures are nominal.
CDS is nominal, we have 2 frames buffered.
Copy, thank you. Telecom systems lead.
Telecom is nominal, good SNT.
Everything is nominal. Copy, thank you. Radio science systems lead.
Radio science is nominal, signal levels are nominal, the residual frequency is starting.
The Cassini-Huygens probe was first launched in 1997, around 20 years back, with the goal of reaching Saturn by 2004. Now, for a never-attempted-before venture, the spacecraft has since completed several runs around the gas giant, studying its unique moons and rings.
Flight director systems lead. Everything is nominal.
Copy.
We should once again tell the viewers that Cassini-Huygens probe was first launched 20 years ago in 1997 with the goal of reaching Saturn by 2004 for a never-attempted-before venture. The spacecraft has since completed several runs around the gas giant, studying its unique moons and rings.
Sure. So we have our computer that's controlling our pointing has different modes, and it's smart enough to know when we start having to fight a little harder. So we heard that the computer acknowledged that we start having to fight a little bit.
Okay, thanks. We were remarking earlier, it's incredible, this entire spacecraft runs on 600 watts of power. How much power is that?
Yeah, about half a hairdryer.
Wow.
That's all we got right now.
I won't even talk about how little fuel we have left. It's about 1% plus or minus 2%. So that's one reason we're heading into Saturn's atmosphere tonight. Under 3 minutes now. We should definitely emphasize we don't know exactly when we'll lose signal. It depends on the Saturn atmosphere and how well the thrusters fight. So stay tuned. Radio signal looks wonderful. X-band and S-band, 2 different radio bands, still getting the signal from Cassini.
We're approaching about 10 degrees north latitude on Saturn. 3,000 miles from the cloud top.
I remember seeing we were going to hit the atmosphere about 77,000 miles an hour. I see we're close. So. 2 minutes and counting.
Oh, we're starting to exit the...
This is ACS-1.
Go ahead, ACS.
We're still waiting for transition to high rate mode, but it looks like we're going to start accumulating thruster on time at a higher rate now, and our attitude control error is starting to be more active.
Copy.
That means we're just starting to sense the atmosphere, right?
Yep. We can start seeing the spacecraft starting to lose the battle with the atmosphere.
Systems ACS-1, we just had the transition to high rate mode, and with this we're going to start seeing thruster on time accumulating very quickly, and the deadband is going to clamp down to 0.5.52 millirad, and we are in the atmosphere.
Copy, thank you.
Roughly 1 minute to loss of signal.
Systems, this is Nav. Go ahead, Nav.
We can confirm what AACS have told you. Copy, thank you.
Across 10 degrees north latitude, altitude 1,000 miles.
So we're just starting to see the thrusters fire more and more. Yeah.
Radio signal still holding. 30 seconds.
Systems lead, mission planning.
Go ahead, mission planning.
Spacecraft has just crossed 10 degrees north latitude, altitude 1,000 miles.
Copy, thank you.
Systems, AACS-1.
Go ahead.
With the additional thruster on time, we're going to also see the deadband start riding.
Copy.
Oh, yeah.
We've crossed our zero time. We'll let Jamie call it.
Flight Director, ready science.
Go ahead, Flight Director.
We have lots of signal at X-ray band and zero band.
Go ahead.
Project Manager, Flight Director.
Go ahead.
Okay, we call loss of signal, loss of X-band at... Call loss of signal at 115546 for the S-band, so that would be the end of the spacecraft.
Project Manager on FSO Quard. Maybe a trickle of telemetry left, but just heard the signal from the spacecraft is gone, and within the next 45 seconds, so will be the spacecraft. I hope you're all as deeply proud of this amazing accomplishment. Congratulations to you all. This has been an incredible mission, an incredible spacecraft, and you're all an incredible team. I'm going to call this the end of mission. Project Manager off the net.
Happened very close to right where we took it.
that's a lot.
Right, so the spacecraft Cassini has ended its 20-year journey, and to talk more about that, I'm joined on the broadcast by the astrophysicist, Mr. Ramesh Kapoor. He's joining in from Bengaluru. Sir, thanks for staying with us here on the broadcast. What exactly happens when the spacecraft makes its way through that last minute? You described it as the glorious last minute the last time we spoke. Is it a combination of the speed of the spacecraft itself and the gravity of Saturn that pulls it closer to the planet?
Yeah, that's right. Because of the gravity, its fall, and the fall speed increases as it continues to fall towards Saturn, and that was just 1 minute. And in fact, I was surprised that perhaps there was a 3 minutes difference from the predicted time of fall, and then the loss of signal from Cassini. But anyway, between the countdown and the clapping, the heart really beat faster, and now I can see on their live TV screens the relaxed faces and people congratulating each other, and it's really a fantastic end of a very long mission, one of the longest ones in history. And this is a first from such a distance in a very distant planet. This is the first orbital mission. See, Pioneer 11, Voyager 1 and Voyager 2 had a flyby, and they sent very valuable information about Jupiter, Saturn, and etc. But here it is a dedicated mission, Cassini, to go in orbit around the planet Saturn and then transmit data over the last 14 years. In fact, the 7 years journey itself was a great matter of study. And today, when there is a difference between prediction and the actual happening, 3 minutes difference, that by itself is a subject matter of study. And ultimately, one is really happy. Cassini has done its great service.
Right, sir. Also, if I can ask you, how much time between the spacecraft making its way into the atmosphere of Saturn and NASA actually receiving the last bits of details or information or the data that was being transmitted? How much of a time delay do you suspect there's going to be?
See, for example, as it fell through, so quite a lot is known about the atmosphere of Saturn beforehand. So calculations indicated that 1 minute will be available for the instruments to continue to work and keep sending the signals toward the Earth. And also one believed that the thrusters will work properly and to the extent as desired. So that 1 minute was obviously a fairly profound calculation. But from such a distance, which is 10 AU, 1 AU means an average Earth-Sun distance, which is about 15 crore kilometers, 150 million kilometers. So 10 AU is quite a large distance. So things happening there, and we are watching them from here. So obviously, a certain mismatch is likely. But this mismatch also is a subject matter of study, as I said. And besides, as the spacecraft entered the atmosphere, those 400 kilometers journey where the density of atmosphere is increasing, as the spacecraft is falling, it's getting heated up to the extent that it starts burning and starts breaking into pieces. So the end is meteoric, like we see the shooting stars in the sky sometimes. So by the same token here also. But during 1 minute, it would have sent certainly some very valuable information about the composition of the atmosphere and how its density varies and how its speed varied as it fell through.
Right, sir, for the layman, for the uninitiated who really don't have that much knowledge about astrophysicists or astrophysics, if you will, and the journey of the spacecraft and what exactly it brings back to the common person. In the simplest terms possible, how would you explain the significance of Cassini and the kind of data it provides to scientists, and especially looking at the future?
See, for example, ever since we gained consciousness or we became aware of the world around, we have been investigating. Everybody is an investigator, for example, and some people tend to be more active than others. They will be, from practical point of view, will be called scientists. Now, the main idea is to know the world we live in, the universe we live in, and how things came into being, and what runs the whole show. So we know about the various kinds of forces, fundamental forces. We also know the structure of matter. We also know the various details of, say, the solar system, how distant the moon is, how distant some other planets are, and how long it may take for one to reach there, and what kind of things to expect. We are talking of settling down on Mars or building stations on Moon. So obviously it's a part of the same journey. We want to know more. And the fundamental question is how the universe came into being, how the solar system was formed, how Earth was born, and all of that. So as we looked into these questions, so there are side questions, still smaller questions. So it's an endless process so far as research is concerned. So right now it gets so detailed that to summarize in a few words Cassini's achievements will be really difficult. But one thing I can say, we now know more about Saturn than we did 20 years ago, and it has been a wonderful journey. And in fact, one of the scientists at JPL commented that when she joined this mission, her daughter was young, and now 20 years later, her daughter's daughter is of same age. So you see, in one generation's time, quite a lot has been learned, and quite much of it will start coming into different research papers, and then we will know much more about the planet.
Absolutely. Also, if I can ask you, sir, what's the significance of Saturn? Why this planet specifically that's intrigued so many people and has led to the launch of the Cassini spacecraft to start with? What sets Saturn apart? See, we have 8 main planets in the solar system. Pluto was dethroned, but people are wanting it back to be a planet. So other than Pluto, we have 8 planets. So inner 4 planets are rocky: Mercury, Venus, Earth and Mars. But beyond Mars, the planets are gaseous. They are gaseous, and Jupiter and Saturn both have, in terms of composition, hydrogen and helium. These are gaseous planets. We know very little about them because it's a very thick atmosphere that surrounds. We don't even know what is the size of a solid core in case there is one. So about Jupiter, it is said that it's a failed star, but had it been a little more massive, then perhaps it would have been a binary, it would have made Sun a binary star. So Saturn is somewhat smaller than Jupiter, and these are the biggest planets in the solar system, and we want to know more about them. And for example, Juno arrived at Jupiter last year, and then it is doing rounds of Jupiter and trying to send information down back to Earth. By the same token, Cassini had been sent much earlier, and Saturn has been a mysterious planet. It's more distant compared to Jupiter, in fact twice as farther out, and so a lot needs to be done, and obviously more probes will be sent in the future, and the whole thing goes on. Absolutely. Mr. Ramesh Kapoor, thank you so much for joining us here on WION.